Welcome to Nano Zorro, the podcast of Tech Zorro, presented by Juditova. Engage with your ears about engineering, development and inventions, as well as interviews with experts and hobbyists. You will learn to make better decisions with your designs, programs and manufactures in order to optimize and develop your products and services, or just for fun. You can find the show notes from the episode, the transcription, and much more by entering to techzorro.com/podcast. And now your host, engineer, crafter, and tech enthusiast, Juditova.
If you like this podcast or the blog, and you do want to support the show, go to our site in Patreon to contribute with a monthly donation. You will have early access to its episodes, you will be recognized as a Patreon in the website, among other benefits. There are several tiers available, starting from $3, or if you feel altruist or generous, there are superior tiers. You just have to go to the website techzorro.com/Patreon. In the show notes or description, you will find the link. We will kindly appreciate all contribution. All right then, let's start with today's episode. Welcome to episode number 8 of the podcast Nano Zorro. I'm your host, Juditova, and welcome to an episode about power electronics. Today we are going to talk about variable frequency drives, an uncommonly competitive device you will want for your three-phase induction motor. So what is this exactly? Well, let's get a proper introduction. AC induction motors can be transformed into a highly controllable machine. With this electronic device, as I just mentioned, variable frequency drive, or VFD for short, a motor can have an ideal and directly proportional power-speed ratio while maintaining the torque constant in nominal conditions. Wow, that sounds incredible, right? In some models, the input is a monophase connection, which means just two wires, and the output is a three-phase connection. Other words, 3 wires, which makes them totally convenient for places where three-phase connections or wiring isn't available. Let's see why variable frequency drives or VFDs are highly desirable. So what are AC three-phase induction motors anyway? Well, let's first begin explaining what are these alternating current motors. They are so popular. In fact, they exist, I guess, since 1889. Imagine that. Okay, so this motor owes its popularity to its wide range of advantages over other motors. It has a long life service, low cost, low noise, is efficient, I think above 85%, and it can be operated directly connected to the three-phase power line without requiring an additional controller. Very convenient. The operation of the motor is based on alternating current flowing through the stator. To create a variable magnet field, it induces a current that flows through a non-ferrous rotor bars to generate a magnetic field. This one is produced in the air gap, which is rotating at synchronous speed. However, the rotor will rotate at a different frequency and will depend on the number of pole pairs of the stator. A cross-section of this motor is shown in the blog post that I will leave in a link below. There are two types of rotors for this motor: wound motor and squirrel cage rotor. So now how it looks like the torque-speed ratio. The typical torque-speed graph from a three-phase induction motor is like a curve that has its peak a little below the nominal speed, the actual speed that runs at free running speed with a minimum of slip. The torque output depends on the speeds of the rotor. As load increases, speed and the consequently torque decreases, which means that the force, quote unquote, that the motor can provide is severely affected. The maximum torque occurs at a lower speed than the rated speed of the motor, which is, in other words, the ideal one, which is the free running speed without any load. For example, a 1800 RPM motor will typically rotate at 1710 RPM under no load. But with the application of the variable frequency drive, or VFD, this curve changes significantly and becomes appealing for industrial machinery. So we have talked a lot about variable frequency drive. So what is it, and what makes this device so special? It's an electronic controller that transforms the input voltage, which could be either AC or DC, to convert it into a variable voltage and frequency source to connect to the terminals of the AC induction motor. So to put into a perspective, it looks like this. A sine wave power, which is the AC voltage from the outlet, comes into the variable frequency drive, and it transforms it usually into a DC power through a DC converter. And then from this DC stable source, it transforms into the desired voltage and frequency that it has to be applied to the AC motor, which is not necessarily the same one that comes from the power. In fact, if you live in a country where the standard is 50 Hz, you can attach a 60 Hz motor into the variable frequency drive and it will work just fine, because you have to digitally through a control panel set the AC frequency of that motor is actually 60 Hz. But it goes beyond that, because it is actually very maneuverable, this frequency and voltage that it receives. Because if you want to have a 25% of the nominal speed of the motor, you can have it with a click of a button, really, literally. For example, if the desired output speed is 50% of the nominal, the VFD adjusts the frequency to the half and voltage to its half in order to compensate the magnetic field, which is a formula that that induction motors have. So when you lower the voltage and the frequency by half, the resulting speed of the motor also reduces by half, which is incredible. Imagine that. You can actually control the speed of the motor. This may not sound like a novelty because, we have plenty of motors that we can adjust the speed. Let's say home appliances or hardware tools, but they adjust the speed of the tool, of the appliance, inefficiently, or they convert it into a DC and use it with a DC motor. But instead, this product actually can efficiently control the speed and maintain the torque optimally at 100%, which means doesn't matter if it's a low speed rotation or maximum or nominal speed rotation, it will retain this speed, which is, wow, this is awesome. Besides a power input and output, there is also a controller input and sometimes a feedback output. It serves to an operator an easy-to-reach panel to control mainly the speed of the motor. However, it is explained here in this episode later on, there are far more benefits than only adjusting revolutions per minute in the machine. When a VFD is attached to a three-phase induction motor, its advantages and benefits can actually be compared and are quite similar to a brushless DC motor, or BLDC for short. Let's explain all of this in the next section. Advantages and savings using a variable frequency drive. First of all, control and maneuverability. Okay, it allows an operator to control the speed of the motor. Previously, this wasn't an easy task since the voltage and frequency of the desired speed must be proportional to the nominal voltage and frequency of the motor. Let's take, for example, a three-phase induction motor with these nominal ratings. Voltage 220 volts AC, frequency 60 Hz, speed 1800 RPM. If an operator will like to lower the speed to, let's say, 25% of its nominal speed, then it will have to rotate at 450 RPM. Then a VFD has to adjust voltage and frequency proportionally to match the desired outcome. For example, for 25%, the voltage will have to be 55 volts AC. It will have a frequency of 15 Hz to reach this 450 RPM, which is the desired outcome. What if the output has to change to 75% because you realize that 100% is like too much speed? You require a little less. Well, at 75%, you will have to give to the motor with this variable frequency drive 165 volts, 45 Hz to reach the 1350 RPM. Now that's convenient. I remember that once I was working in a construction site and the brick cutter used to rotate at 3600 RPM. But when we begin experimenting with VFDs, we found out that this brick cutter was rotating at too much speed. When it's too fast, then it loses also the safety and maneuverability characteristics. So the operators told me that they required less speed. So let's see. We began with 25% and maintaining the torque. I will explain that in the next session. And it was still not so fast. So we incremented to 50%. And the operators told me that that's it. The handyman said that that's what they needed. Nothing more. They were able to cut the bricks much easier than before. And with savings. I will explain that in the later section. The new torque-speed ratio. Using a variable frequency drive, as stated before, respects the ratio voltage-frequency. These two variables affect the magnetic flux of the machine, and as long as it remains the same, the torque output of the rotor remains unchanged. Excuse me, I got excited. Until the nominal values of the motor. For practical uses, from 0 to 100% of the nominal speed, the motor will always have the same torque. Wow, amazing. On the other hand, the power usage, or watts or HP, horsepower, is proportional to the speed, which means that if you use it with 50% speed, then it means that you will consume 50% less energy. Do you imagine how powerful is that? As far as I know, the variable frequency drive could start operating a motor from 5% of the nominal speed. And wow, that's an incredible control. Slow start. Typically, an induction motor uses 4 to 7 times more current than the machine uses normally at normal operations. This hits the lifespan of any motor in the long run, but it affects other circuitry connected to the AC line, like home appliances, for example, or even the transformer in your home or neighborhood. Furthermore, if your transformer does not have enough capacity or is located far away, then your motor probably won't start. Remember that there is no rush. The motor could start in 10 seconds from 0% to 100% nominal speed to reduce any peak current consumption. Regenerative braking. Some models of VFDs incorporate this very interesting feature, which is a special method of dynamic braking. It consists in the returning of the energy back to the grid in exchange of the motor slowing down. Its efficiency depends on many factors, but it is possible. Slow and safe rotation switch. Is the motor rotation in the wrong direction? With a VFD, a simple switch could be used to reverse the rotation of the motor. Typically, once the switch has been activated, the motor will slowly decrease its speed until reaching 0 RPM, and then it will start in the opposite direction in the same time it took to stop. This time is entirely configurable. Lower power consumption. Remember the formula for power. Power equals torque times rotation. If the torque is constant, then power decreases as rotation decreases. This is very attractive from the economic standpoint. Higher efficiency and more convenience. Besides the lower power consumption, proportional to the speed, now three-phase motors have higher energy efficiency, which means they require less power to operate with the same torque output. It is notably higher than monophase motors and ridiculously higher than fossil fuel motors. Some models of VFDs have only 2 input cable and 3 output cables. It makes an important feature because small industries and condominiums doesn't have 3-phase connections. Therefore, they can leave behind less efficient motors to work with variable frequency drive. And lastly, less maintenance. With less peak current consumption and less heat dissipation if used at slower speeds, VFDs can reduce maintenance, downtimes, and other complications involving induction motors. Well, that's all for this episode. Today, you have heard about the 3-phase motor and the typical torque speed curve, as it was briefly explained. Afterwards, the benefits of VFD or variable frequency drives. I hope that you have liked this episode and share it if you think that other colleague, other friend of yours will find it useful. I hope you have enjoyed this episode so far and that you have learned something useful for your next craft or project. Before you go, I just need a favor from you. Go to the application where you are hearing this right now and leave us your honest review and a like or a rating from 1 to 5 stars. This way, more people will be able to find this episode and enjoy it as well. It will mean so much. Juditova says goodbye. Until next time.
That's all for this episode. We hope that you found a moment of enlightenment and that you have enhanced your skills or cleared some doubts. For more interviews, tutorials, blueprints, and advice, go to the website techzorro.com/podcast. Juditova expects you in the next episode. Don't forget to subscribe. Happy crafting!